Okay, so problem 3b has this implement pruned, which is a function that takes in a tree instance t, and if t contains at least one fruit, it will return a tree instance with only the nodes of t that appear on a path from the root to the fruit. If t contains no fruit, pruned if t returns none, and just a note, calling pruned on t should not modify t. Okay, so this kind of last sentence here is actually pretty important because it tells us that we should never be actually modifying t. Instead, we would want to return a new tree instance. So this kind of tells us that somewhere in our code we should probably be calling tree like as a constructor in order to just create our new tree that we return. Okay, so looking at the structure right away, we're kind of met with this tree recursion again. So we have our if base case, and then our recursive case this time is split up into multiple different lines. So that's just something to keep in mind. So as always, let's kind of approach our base case first. So if we have a fruited branch of t, or sorry, if t is a fruited branch, so that means t looks something like root and then leaf. Then what do we want to return? Well, we just want to return a tree instance with the nodes that appear on a path from the root to a fruit. So in this case, these are the only two nodes and they're both on that path, right? One is the root and one is the fruit. So we're essentially just going to return t. Cool. Okay, so now let's move on to the slightly more complicated recursive case. The first thing we should do is just read this line and try to understand like what is going on in here and how we could use that in our solution, because we know they didn't just give us a line for no reason, right? So cut here is essentially a new list that contains all of the pruned branches of t. So it notes that some of these branches might be none because if the branch doesn't have at least one fruit, then it's just going to return none as per the problem specifications, right? So for example, if we had a tree that looked something like this, so I'm just gonna draw a simple example. Okay, so here we only have one fruit. So this 3 right here is going to be the only fruit because it doesn't have, or it has a parent, but it has no siblings and it's a leaf. For example, 5 and 6 wouldn't be fruit because they have siblings, right? So what what pruned of t should return is essentially just a tree that contains these nodes, and we're not going to worry about the ones on the right, right? Oh, okay. So essentially what happens when you call pruned on all of the branches, well, cut is going to contain a 2-element list because it's going to contain an element for every branch in t.branches. And one of them is going to be this tree, right? But the other one is actually going to be none because we know that pruned by a recursive leap of faith should return none if the tree that's passed in has no fruit. So that's why has no fruit. That's why essentially what cut is going to look like is this list here. Sorry. So what's going to happen if we have a cut list that looks something like this? Well, our problem asks us to essentially return a tree with only the nodes of t that are on a path to a fruit. So we know if our cut list looks, for example, like just a bunch of nones, we know that there's no fruit inside our cut list, so we can pretty much safely return none. But if we have just one element that isn't a none, it's like one tree instance, then we're going to want to return the path from the root all the way to that fruit inside this tree instance. So yeah. So what we're really interested in is if any of these elements inside our cut list isn't none. So what that really can be written out as in code is if any of cut. So if any of cut then what are we going to want to do? We're going to want to return a tree instance that starts from the root and contains all the paths going down to the fruit. So like we kind of noted when they told us that we shouldn't modify t, we're going to use our tree constructor here where we call a tree that takes in, we want to start from the root, so it takes in t.label. Oops. And then for the branches of t, essentially we want all of the branches that are in our cut list that aren't none, because those are the ones that contain a path to a fruit. So essentially we know that our branches are going to be a list, right? So we're doing some kind of list comprehension here. So we're going to do every branch of t, so every b for b in t dot branches, or sorry, not t dot branches, in cut, right? But we don't want all of the elements of cut. We only want the ones that aren't none. So what we can do this is, or how we can do this is with a if statement. So if b is not none, which is just the same as if b. So boom. And essentially what that's going to do is it's going to construct our tree starting from the root node and then containing all of the prune branches if they're not none. Because remember, cut contains all of the prune branches of t. Okay, so this seems to me like it should be our solution. So just as a quick sanity check, let's make sure that the options that we wrote down are actually multiple choice options. So for part 1, looks like t is an option, so good, we're going to bulk that in. Part 2, any cut is right here. And then part 3 was actually just a fill in the blank, so I'm just going to copy this over. Duplicate. Alright, cool. And that should be everything for this problem.